Jai Hind children. We are dealing with chapter 5, that is acids, bases and salts. In this chapter you are going to come across different substances which you see in your daily life, and you will categorize them in acids, bases and salts. So now let us first try to understand what do we mean by acids and bases. Acids and bases are a way of classifying compounds based upon what happens to them when you place them in water. An acid is a substance that yields hydrogen ions when dissolved in water, and a base is a substance that yields hydroxide ions when dissolved in water. These hydroxide ions are also referred to as hydroxyl ions. Now, when we say acid gives hydrogen ions in water, how this happens? When you actually deal with acids, they yield hydrogen ions in water, we say so. Why we say so? Because aqueous solutions of acids are formed when you put acids in water. Now question comes here, what do we mean by aqueous solutions? Aqueous solutions are substances when displaced in water. Aqueous here refers to water. Whenever you place a substance in water, we call it that aqueous solution is formed. Similarly, base on dissolution in water gives hydroxyl ions. So when you put base in water, we actually say aqueous solution of base is formed. Now next, this is a diagrammatic representation. When you put acid in water, it forms hydrogen ions, and when you put base in water, it forms hydroxyl ions. So acids furnish hydrogen ions in water and base furnish hydroxyl ions in water. So on the basis of what types of ion they furnish or they give in water, we categorize them as acids and bases. Now let us see the common acids which we come across in our daily lives. All of you have seen lemon and consume lemon also. Lemon contains citric acid. Similarly, vinegar, which is generally put in your noodles and all, chow mein and all, that contains actually acid. Vinegar contains acetic acid. So these are common examples of acid which you come across in your daily lives. Besides that, substances like spinach contains oxalic acid. Then we have tamarind that contains tartaric acid. So these are some common acids which you come across in your daily lives. Now let us see examples further given. Some characteristics of acids given here, which helps you to identify that how we can find out that the given substance is acid. Acids first of all have a sour taste. You know, lemon has a sour taste, so we say that it contains acid. Actually, we don't rely on the taste test for substances. It is not safe. Now we say acids are sour in taste. This we say in terms of edible substances, edible acids which can be consumed. Otherwise, lab caution is that we don't allow you to taste any substance. See, since these acids which we are talking about here, like vinegar, lemon, they all contain edible acids. That is why we are telling you that acids are sour in taste. Otherwise, if you are provided with any sample of acid, you are not supposed to taste it. Then what are the other means of finding out? That we'll come to know as we move in the chapter further. Now, other important precaution to be taken while handling acid. Acids may burn your skin. So we can say acids are corrosive in nature. They have corrosive action on skin. Then they turn blue litmus red. Now the question comes here, what is litmus? Litmus is actually an indicator which we use for identifying acids and bases. We will come across these indicators later in the later part of the chapter. Now let us see some other examples of acid which are given here. These are hydrochloric acid, then we have sulfuric acid, acetic acid you already know. Now these hydrochloric acid and sulfuric acid are actually placed in the category of mineral acids, and acetic acid is actually placed in the category of organic acids. Now some common bases. Soap contains base. Sodium hydroxide or potassium hydroxide is the base which is present in soap. Similarly, your window cleaners and all contain base called ammonium hydroxide. Then you have calcium hydroxide, which is present in lime water, which we use for identifying the gas carbon dioxide in the lab. Then characteristics of bases. As acids have sour taste, similarly bases have a bitter taste. But this is only applicable for edible bases. Then bases can also be poisonous and may have corrosive action on skin, especially the strong bases like sodium hydroxide and potassium hydroxide. Then we feel slippery bases when we touch it. Just put bases on our hand and we try to rub up between the base between our fingers. We'll find that we feel slippery. So we can say bases are soapy to touch. Then as acids turn blue litmus red, similarly bases turn red litmus blue. Then we come across some other examples of bases like sodium hydroxide, potassium hydroxide, etc. They are the bases which we come across in our daily lives. Then distinction of acid on the basis of dilute and concentrated. Dilute acids are those which contain large amount of water and a very small amount of acid in it. Means dilute acids will contain lot of water in them. Then concentrated acid comparatively will have large amount of acid and very less amount of water. So question can come to distinguish between dilute and concentrated acid. Dilute will have lot of water in it and concentrated will have lot of acid in it. Then another way of distinguishing acids and bases is strong and weak acids. Strong acids are those which release lot of hydrogen ions. Weak acids are those which release comparatively fewer number of hydrogen ions. So this distinction into strong and weak acid is totally based on the number or the amount of hydrogen ions produced by acid when it is placed in water. Strong, large amount of hydrogen ions. Weak, comparatively very fewer number of hydrogen ions. Then next is indicators. We have talked about litmus indicator earlier in one of the slides. Now actually we need to understand what are these indicators. They are the special type of substances which are used to find out whether a given solution or a substance is acidic or basic in nature. These indicators will show different colors in acids and bases. And from their specific colors, we can identify that a given substance is acid or base. Common indicators which we use in lab are litmus, and then we also use indicators like phenolphthalein. So there is distinction given to indicators also. Indicators which are defined naturally, which are obtained from nature, they are called as natural indicators. For example, we have litmus, we have turmeric, we have China rose extract. All these are natural indicators because they are obtained from nature. Then we have synthetic indicators also, which are man-made. For example, phenolphthalein and methyl orange. These are the common indicators which are used in lab for identifying acids and bases. When we talk of litmus, litmus gets red color with acids, means it turns blue litmus red with acids. And with bases, litmus turns from red to. So this is from litmus. Then if we talk of phenolphthalein, phenolphthalein gives no color change with acids. Its original color is colorless. So with acids, when we say no color change, it means colorless remains colorless. But if we talk of bases, phenolphthalein gives pink color with bases. So by specific colors we can identify that the given substance is acidic or basic in nature. Then you might have heard about acid rain. Acid rain is the rain water which contain acids. So you know pollutants, there are various pollutants present in air. And if we talk about pollutants like sulfur dioxide, carbon dioxide, nitrogen dioxide, etc., they all are acidic gases present in air. When they dissolve in water, they will result in formation of acids. And when rain falls, along with it comes the acid which is present in the atmosphere, and we call this rain as acid rain. Then you see the harmful effects which acid rain may cause. It is harmful for plants, it is harmful for vegetation, it is harmful for monuments because it can corrode the monuments. Then it can harm aquatic life, it can harm vegetation, it can harm monuments, it can even destroy crops. So acid rain is harmful. So we should make our best efforts to reduce the amount of pollutants in air so that our nature is not destroyed. Then next comes neutralization. The process of neutralization is possible when acids combine with bases. Acid react with bases to form salt and water, and in this process of combination of acids and bases, heat is also produced. So we can say neutralization reaction is a reaction in which acid combines with base to form salt and water, and since heat is produced in this reaction, we can say that this reaction is exothermic in nature. Exothermic, in which heat is produced. Now we will come across how is neutralization helpful in our day-to-day life. Neutralization is helpful as it relieves us from indigestion. Now the question comes here first, how this indigestion is caused. We know in stomach hydrochloric acid is produced for digestion of food. And when this hydrochloric acid in stomach produced is in excess, it results in indigestion. To get rid of this indigestion, we need to consume antacids like you consume ENO and all. They contain a base, and this base is generally magnesium hydroxide. This neutralizes the excess acid produced in the stomach and thus relieves us of indigestion. Then ant sting. Generally you might have heard in ant bite. There is formic acid present. So this formic acid enters our skin when ant bite is there. In order to get rid of this acid which has been injected in our body by ant, we need to rub it with base. And generally the base used is moist baking soda, which is sodium hydrogen carbonate. Or we use galamine solution, which is zinc carbonate. Since these compounds are bases, they will neutralize the effect of acid which is induced in our body. Then soil treatment. In soil treatment generally we come across that there are crops which grow well in basic or neutral soils, and you may find a place where the soil is acidic in nature. In order to convert this acidic soil into basic soil, we need to add bases like lime, slated lime, etc. Lime is calcium oxide, slated lime is calcium hydroxide. These bases will neutralize the acidic effect of soil and will change it to basic nature so that it is fit for growing those crops which grow well in basic soils. In factory waste which is produced may contain various acids. We need to neutralize them before dumping them into water bodies so that they are converted to such substances which are not harmful for water bodies. So this is how neutralization is helpful in our daily lives. Finally, to sum up, we will see that what are acids. Acids are substances which produce hydrogen ions in water. They taste sour, they can corrode metals, and they react with bases to form salt in water, and this reaction is called as neutralization. Now, for bases, to sum up, we can say they produce hydroxide or hydroxide ions in water. They have bitter taste, they are soapy to touch, and they react with acid to form salt in water, and this reaction is called as neutralization reaction.